Hello guys, today we'll talk about the regeneration, which is also called recyclability or renewal or restoration. This is a very critical aspect to stimulate the absorption competency of the used adsorbent for water treatment. There are a number of techniques that is being applied for finding out the regeneration potential. That is chemical treatment, that is thermal and biological degradation or photocatalytic, or sometimes we also use thermal desorption or decomposition, chemical desorption. In case of chemical, we can use different kind of eluent, or we can also use microbial assistant adsorbent regeneration. Also sometimes we can also use using a steam or using some sonication also. These are different kind of techniques. Today we will see how we perform these experimentation in the lab. Hello guys, as we saw earlier, a brief discussion about the regeneration. So in today's video, we will be doing regeneration using two different kind of adsorbent. First of all, this is our methylene blue solution. We don't know the concentration of this, so we'll first find out the concentration of methylene blue. So the methylene blue concentration is around 19 ppm. Now we have chosen two different kind of adsorbent for regeneration. First is my tea waste and second is my raw pozzolana. I'm transferring around 100 milligram of both the adsorbent. The second wire also, conical flask, I'm also transferring 100 milligram of the adsorbent. So first adsorbent is tea waste hydrochar and the second one is the raw pozzolana. So the next step is to transfer equal amount of methylene blue, transferring around 200 ml of the methylene blue to the vials. We know the concentration of the pollutant and the pH is neutral here. So now the solution is already transferred to both the conical flasks. The first one has hydrochar, tea waste hydrochar. We'll put this whole mixture here and putting to the starting the Orbi shaker. We'll first set the time. So I would set the time around 8 hours. And RPM I would set around 272. Save now. Now I would start the system and run for 8 hours. It is the first the adsorption cycle, or you can say the first generation cycle, and the second set we would pick out and weigh the concentration. Then we would desorb it. So let's start the first step, closing the fume hood, and after 8 hours we'll measure the concentration. This is first set of regeneration done. Now we would add this to this vial and centrifuge, and then we'll find the final concentration. Now centrifugation is begun. After 10 minutes we will measure the final concentration. Now for the first set, for the tea waste hydrochar, it's almost 0, and the pozzolana, it is almost around 60, or you can say more than 50% removal. The next task is to desorb this. We did the adsorption, now we will desorb. For desorption we have to choose the right eluent, or you can say the right reagent. In this case I'm using methanol, or we can use ethanol or NaOH, or also we can use the combinations, okay, like NaOH plus Na2CO3 or NaOH plus sodium bicarbonate. So there are a lot of eluent used as per the literature review. This one, both ones what I have done, I have decanted. So we can also centrifuge to separate the adsorbent from the liquid solution. I've just simply decanted, remove the top layer. To that I am going to use the 50 ml of methanol. We will be doing this so that all the ions that has adsorbed on the adsorbent, so that they are dissolved or they are removed, so that again the pores are available for the desorption or adsorption of the pollutant. Do this for 2-3 times, and then we will also wash with the deionized water. So we will skip this step. I'll just show you the addition of the desorbing agent. You can see when I added, so all the color which has adsorbed and the pollutant, they are coming up. After addition of the methanol or the desorbing agent, we will shake it for a couple of hours, 1 or 2 hours. Again we will decant the left out the solid from the top, liquid from the top. Then again we would add methanol. So we will continue this process for 2-3 times, and at the end we will also wash with the deionized water, and then we will dry, and then it will be ready for the second adsorption. For the second regeneration cycle, you can see the mass there is a loss of mass in case of the pozzolana. So it's around 79.38 milligram. In case of hydrochar, there is more loss of mass from the first cycle. Depending on the masses of the retrieved adsorbent after the first cycle, we will increase the volume of the pollutant that is to be treated. In case of this one, we will add around 78, and this one we will add around 73. Now we will shake this for around 8 hours, and then we will take the final consideration. After second regeneration cycle, you can see here, this is the hydrochar, and this is for the pozzolana, raw pozzolana. So I've already centrifuged the sample and prepared it out. And you can see still there is around 50% drop, or you can say around 45 to 50% drop. And in the first cycle it was around more than 50% removal. So there is a little drop in the second cycle. Now in case of hydrochar, the removal is around 99 or 98% removal. We can conclude that the hydrochar, tree-based hydrochar, has a greater potential in removing methylene blue from the aqueous medium, and it has higher regeneration potential as compared to the raw pozzolana, because there is a very minute drop from the first cycle. So we will stop here, and we can also go to as much cycle like 5-6 cycle also, and here we used methanol. We can also use the other desorbing agent, and then we can check its regenerating potential, or sorry, we can find out its desorbing potential.